Today we're going to go over inverse functions. Example 1, we're going to determine whether the function is one-to-one first. Only one-to-one functions have inverse functions. So this is going to be one first steps that you have to check before finding inverse functions. So let's see if we can tell if given function is one-to-one. There are a few ways of telling if it's a one-to-one functions. One way will be checking or testing the points. The other way is using the horizontal line test. So for example, the first one, f of x equals to 2x minus 3. We know this is going to be linear functions because the highest power is 1. We call this is linear. And what do we know about linear? We know that if we graph the line, this equation will have something like this graph. Linear will have straight line, and because it's positive slope, the top end is going to be going toward right? So this is the shape of the graph you're going to have. And if we draw a horizontal line anywhere on your graph, if it only meet one point, then it's going to be a one-to-one functions. So that's one way of telling if given function is one-to-one function or not. So in this case, you will say yes, one-to-one functions. And you can also test that by testing a point, right? No matter what x you end up giving, you always get just one y. So 1x for 1y. We can test maybe x equals to 0. We're going to get negative 3. If we wanted to test 1, we get 1 times 2, and minus 3 is negative 1. So, no matter what value you're going to plug in, you're going to get different x. That's why we have this line for the linear equation also, right? So this is going, no matter which way you're doing it, this is going to be one-to-one functions. What about then the other one? We have b, f of x equals to x squared plus 1. What about this one? Do we know the shape of the graph? This is going to be quadratic, and your leading coefficient is positive, so parabola going up, right? So this is the graph of your parabola, quadratic. So if we draw horizontal line anywhere on your graph, it meets 2 points, not 1, 2. So if it's more than 1 point, it's not a one-to-one functions. And again, you can test point too, right? But horizontal line test is usually the easy way at this point because we know the shape of the functions. So next example we have is we're going to see if given functions are inverse to each other. This is something you have to do at the end when we're looking for inverse. Once you find inverse function of given functions, we also have to verify they are inverse to each other. So example 2, we're going to try that. How we're going to verify if those two functions are inverse to each other. So we first wanted to know if the second function, in this case, g of x, is inverse of f of x functions. So how do we tell that? Well, we're going to replace g of x function into f of x functions. If this you end up getting equals to x, then you will say, yes, g of x is inverse of f of x functions. And also you need to test the other way around. So g of f of x function, if you get x, then f of x function will be also inverse of g of x functions. So if we test that, let's erase, because we don't know if this is what we're going to get. So let's erase this and test out. So this means you're going to replace g of x into f of x, right? So you start with f of x. Wherever you see x, you're going to replace g of x, right? So you have 12x, so instead of that x, you're going to replace g of x. And when we simplify this, and if we get x by itself, then we know g of x is inverse of f of x functions. We do the multiplications before additions. So we will get rid of common, because this is the same as 12 over 1, right? Common between numerator, denominator. Then you will end up getting 100 plus 1 times x minus 100. And when you open the parenthesis, you get plus x minus 100. And then you can get rid of positive 100, negative 100. And then you get x by itself. So this one checks out that g of x is inverse of f of x. Then we need to try the other one too. So we don't know we're going to get x yet. So let's this time replacing f of x inside of g of x. Then we're going to start with g of x, but wherever that I see x, you're going to replace by f of x, where f of x is 100 plus 12x. So then you need to simplify the numerator first. So you have positive 100, negative 100 cancels out each other. And you have 12x over 12. And 12 and 12 cancel out each other. You get x by itself. So they checks out. You will say yes. Inverse to each other. What about if you have b? H of x equals to cube root of x minus 1. Kx equals to negative 1 plus x cubed. Let's see if they're inverse to each other. So we also need to try both way. So we do h of k. Oh, that's x. And then we do k of h of x. So that means you're going to replace k into you're going to replace into k into h of x. So you will get, you start with h, and wherever you see x, you're going to replace by k. And then you simplify, right? So this, when you open the parentheses, you get negative 1 minus x cubed and minus 1. Which you get cube root of minus 2 plus x cubed, where you cannot simplify it any further, right? So, I don't even have to test the other one because kx is not inverse of hx. So you don't even have to test the other one. But if you still want to do it, you can. It looked like you're going to have negative 1 plus x cubed, which is cube root of x minus 1 cubed. And you get negative 1. Cube root and cube cancel out each other, and you end up getting plus x minus 1. Again, you get x minus 2. This is not same as x. And this is not same as x. So they are not inverse to each other. But if you see one that's not inverse, you don't have to try the other one. Example 3, now we're going to try to find the inverse functions. The given function is f of x, 7x minus 5. So remember we mentioned that in order to have inverse function, it have to be one-to-one functions. So the step 1, we need to make sure given equations, given function is one-to-one. And this is linear equations. So linear equation, when you draw the horizontal line test, it passed the horizontal line test because it only made 1 point. So it will be, one-to-one functions. And because it's one-to-one functions, you should be able to find inverse functions. In order to find inverse functions, first you need to verify it's one-to-one. Second, you need to replace function notation with variable y. And then step 3, you wanted to replace x and y place. So y become x become y. And then step 4, you wanted to solve for y. So isolate y. So first thing you need to do is adding both sides by 5 and divide both sides by 7. And if you have any inverse, this is going to be your inverse. So the last thing you need to do is checking. How do we check? We check using the other method. Remember from example 2, right? We're going to check. And let's say I'm going to rename this as maybe g of x, right? So then I will check as f g of x first, then f of x, all the x I will replace by g of x, and see if I get only x by itself. 7 cancels out, so you get x plus 5 minus 5, which is going to be x. So g of x is inverse of f of x. Now we need to test the other way around. So then when you replace, you start with g of x, so it will be x plus 5 over 7, but all the x you're going to replace by f of x and then negative 5, positive 5 cancel, 7x over 7, which is going to be x. So this 2 verify that g of x is inverse of f of x. So then you could say this is the notation of inverse. So f inverse functions, fx inverse function is going to be x plus 5 over 7. They asked me to find the inverse function of f of x, so I will say f of x inverse is x plus 5 over 7. One more thing that I wanted to go over is finding a domain. So just looking at this right here, the first, the given functions, f of x, 7x minus 5. What's the domain of these functions? Your domain is going to be linear, so it'll be negative infinity to positive infinity. No restrictions, so you're going to have negative infinity to positive infinity, all real number. The range, well, we can look at our graph and can tell our range is going to be also all real number, right? But let's say we didn't know what was range. Then you can also look at the range of domain of the inverse. So what's the domain of these inverse functions? This is the fractions, but still we don't have a variable on denominator where variable is on the numerator. So this one don't have any restrictions. No restriction because no variable on denominator. So your domain is going to be negative infinity to positive infinity. So domain of inverse function become the range of the given functions. So these two should be the same. I'm trying to make it equal sign, but I wasn't able to. So I put an arrow saying that those two are equals to. If you can find, because finding a domain is easier. So if you can find the domain of inverse functions that become range for the given functions. It means the domain of the given functions will become range of inverse functions. Again, domain of inverse function will be the same as range of the given functions. So domain of the inverse functions will be the same as the range of the given functions, and domain of the given function will be the range, same as the range of the inverse functions. And we'll see that using the next example, we will see the domain and range again. The next problem we're looking at it is f of x equals to x cubed plus 1. The first thing we need to know is we wanted to make sure given function is one-to-one function, because only one-to-one function have inverse functions. So let's see if we have cubic functions. We know that look like this. And if we draw the horizontal line anywhere, it will only meet 1, so we know it is one-to-one functions. So this function f of x x cubed plus 1 will have inverse functions. Then we're going to write the function notation with variable y. Next, we're going to switch x and y places. So y become x become y. Once you switch, you're going to solve for y. So you're going to subtract 1. And then get rid of cube by cube roots on both sides. So a cube root cancels out cube. That way you can isolate y by itself. And you have cube root of x minus 1 remains. If if the f of x function have inverse functions, and if we didn't make any mistake between, this should be your inverse functions. We're going to name it as g of x for now so that we can check this out. We wanted to make sure that g of x function is inverse of f of x functions first. So if we replace g of x into f of x, x cubed plus 1 is f of x. So all the x you're going to replace with g of x. And we know cube and cube root cancel out, so you end up getting x minus 1 plus 1. And minus 1 plus 1 cancel each other out, and you get x. So it checks out g of x is inverse of f of x. Let's check the other way around. So we wanted to make sure f of x this time is inverse of g of x. So we start with g of x, and wherever you see x, you're going to replace by f of x. So then we can simplify this by getting rid of plus 1 and negative 1. And then you can cancel out cube root with cube, which you get x by itself. So this two shows that they are inverse to each other. So once you take it out, that you know they are inverse to each other, then we should be able to rewrite g of x into inverse function of f of x notations. Yeah. And let's see if we can find domain. It's easier to find domain for the given function because this is cubic equations. Cubic equation, we know this is going to have negative infinity to positive infinity where there is no restrictions. So this domain of the given function become range of inverse functions. And if we can find domain of the inverse function, what's the domain of cube roots? Cube roots have no restrictions, so that's another negative infinity to positive infinity. So that's going to become range of the given functions. So I'm going to make a connections to show you this domain of the given functions become range of inverse functions, and domain of inverse functions become range of the given functions. And if the problem is ask you to find the inverse function with domain and range, that will be the solutions right here. Let's try one more. C. F of x equals to 5 over x plus 4. what was the first thing we need to do? We need to make sure given function is one-to-one functions. And all the rational function will be one-to-one functions. We learn how to graph them. So if we imagine different types of the graph, and we know when we draw the horizontal line test, it will only meet 1 point. So most of the rational function will be one-to-one functions. So then we will say yes, one-to-one. Then we're going to replace function notation with variable y. Now we can switch those two. And solve for y. So in order to solve y, I wanted to subtract 4 from both sides. And y is on denominator, so I wanted to bring it up to the numerator by multiplying both sides of equations by y. So this will cancel out, where you have y times x minus 4 equal 5. And then when you solve for y, you need to divide both sides by x minus 4. And for now, I'm going to name this as g of x. So we can check. We don't know this is going to be inverse of f of x functions. We need to check this, okay? So when we replace g of x into f of x, we will get 5 over x, where my x is going to be g of x, and plus 4. As you can see, this is going to be complex fraction, so we need to simplify the complex fractions by multiplying this by x minus 4 over 1. And it means you need to do exactly same thing on the numerator. So your denominator is 1, right? So you will get 5 times x minus 4 over 5 plus 4. And you can see that 5 over 5, you can also cancel out. This is going to give you x minus 4 plus 4, which is going to be x. So g of x is inverse of f of x. So we need to check the other way around again. So start with g of x. 5 over x minus 4, but x you're going to replace with f of x. The first thing I need to do is simplify denominator, because you have more than one term on denominator. And you can get rid of plus 4 minus 4. Then you get 5 over x. Complex fraction, so you're going to multiply this by x over 1 to get rid of complex fractions. Then no more denominator, and you end up getting 5x over 5, and 5 over 5 is 1, so that gives you x. So both way, it checks out that g of x is inverse of f of x, and f of x is inverse of g of x. Then we can rewrite my g of x into inverse of f of x notations. This is going to be 5 over x minus 4, right? Right here. And then let's see if we can find domain and range of my inverse functions. Just looking at my inverse function right here, which being fraction form with variable on denominator, we do have our restrictions. Whatever it makes denominator 0 is the restrictions. And let's see what will be the value. The value will be x cannot be 4, right? Since that's the restriction of f inverse functions, your domain is going to be all real number but positive 4. So I could say this is going to be negative infinity to 4 and 4 to positive infinity. So excluding 4 from all the real numbers. And we know that's going to be range of the given functions, right? So this, even they are not asked to find, you should be able to realize that range of this function is going to be negative infinity to 4 to positive infinity, right? Remember, this domain will be same as the range of the given functions. So given function domain is going to be my range of inverse functions. In order to find range from the inverse functions, I cannot see what my range is going to be unless I plug in all this value, and it will take a little bit of time, or if you graph it, right? So instead of doing long work, if I have inverse functions of g of x, right, then domain of the given function will be range of the inverse function. That's what we've been doing it from last two problems. So let's make sure we can find domain from the given functions. Domain from the given function is easier because whatever make denominator equals to 0, right? Denominator is x, so x cannot be. So this x right here cannot be 0. That's the restriction you have for that f of x. It means your domain is going to be all real number but 0. So that become your range. So I have inverse functions of given functions and domain and range for the inverse functions. I have one more problem on my notes. Try them out and let me know if you need help.